irrational denominator. Has the sum of two irrational numbers. One irrational number plus another is still going to be irrational. So you have to figure out what you need to multiply by, and you're only allowed to multiply by a form of what? 1. So whatever you put on the numerator has to be in the denominator. So what are we going to multiply by? You want to tell me, Nate?
The square root of 7 minus the square root of 5.
Yeah, exactly. So when you do this, you end up with 8 root 7 minus 8 root 5 all over what? You get 7 minus the same thing, right? I'll write it out so we can actually see it. That's fine. So you end up with root 7 times root 7 is 7, but then you get minus root 35 plus root 35, and then you get, what's negative root 5 times positive root 5? Minus 5, right? Minus 5. So what cancels in there? Yeah, and it better, because if it doesn't, you haven't rationalized the denominator. So you end up with 8 root 7 minus 8 root 5 over 2. And are you done at this point?
Yeah.
No, you're not.
Minus a negative?
Minus a negative?
Yes.
No, it's not minus a negative. It's minus 5.
Oh, I see.
The minus is on the 35. So you have 8 and 8 and 2. What does that say? You need to simplify that. What does it become? 4 root 7 minus 4 root 5. There would be your final answer. So if you're going to simplify this, you have essentially 4 things to simplify. The cube root of 8, the cube root of a cubed, the cube root of b to the 5th, and the cube root of c to the 9th. Well, what's the cube root of 8? 2. So you could just, first thing you could do is just do it piece by piece. Don't try to do it all at once. It's fine. A cubed, b to the 5th, c to the 9th. Well, what's the cube root of a cubed? A. So now you have 2a times the cube root of b to the 5th, c to the 9th. What's the cube root of c to the 9th? C to the 3rd, right. So you end up with 2a c to the 3rd times the cube root of b to the, and we can keep on going on this because there's 5 b's on the inside of that thing, and it's cube root. So what could you pull? You could look at 3 of them and pull 1 out. So you end up with 2ab c cubed times the cube root of b to the, what's left? B to the 2, exactly. B to the 2. Can you go any further than that? Nope. This right here would be great. Another thing to realize is that since we're going to be focusing on a lot of simplification on the upcoming test, which is tomorrow, you have to make sure that, get the easy stuff. Like, so if you stop there, are you done? Make sure you take that extra step and do it properly. You have to go to there, right? I hate it when it does that. And then for here, just keep on going. You essentially know you're done when you see that power. What's the power underneath the radical? It's 2. You see it right there? It's lower than that. So can you go any further? No. And I just erased that. That's great. Okay. Do you remember what my favorite form is for the equation of a line? Y minus, remember this? Point slope, exactly, right? So if you plug in a point and a slope, you can be done at that point. You guys tended to want to translate it into slope-intercept form. And what's the challenge there? You're used to it. Unless I ask you to do it, don't, because you might make a mistake and it's doing more than you need, or just spending more time doing something that you don't need to do. Time is a huge asset. Multiplication? No. You literally just take this apart like you would with any other variable. So it's plus 1 and plus 4i. There's a little bit of multiplication. You're kind of distributing that negative sign in. What cancels now? Those are gone. And what's it equal? Negative 2. And you're done. That's it. You treat I just like any other variable, but the one thing you know about I, what is I squared?
-1.
That's the truth that you can apply. And because of that, you can disassemble things like I to the 1000th power. Okay. The number one most common mistake when working with imaginary numbers is being a little too careless with negative signs. So when you do this out, Rachel, what's 4 times 4? 4 times negative 9i. And then right here, what do you get? Correct. And then what do you get here? Correct. You have to be very careful here because these go away. That's nice, right? But then you get 6 minus 81 times what is I squared? So this is going to be 16 plus 81, which is 97. It's really easy to miss a negative sign, and then the whole thing falls apart. Super easy. Especially when you have i's and I squareds and negatives and, things like that. So there's one last here. What was it, 160? Let's do that. 490, yep, okay. So let's see this here. 490, this is exciting. 160, what do we have here? Oh, this is a good one. 5x plus 6 minus the square root of x plus 3 equals 3. What's the first step that I really like to emphasize when you do these? Theoretically, could you square first if you wanted to?
Yeah.
You could. It's not really a good idea because you have two radicals on one side, and if you square it, it gets even uglier in a way. Like, it does lead you towards theoretically a solution, but it's much easier if you just add. And I like, if the choice is between keeping it positive or keeping it negative, keep it positive. So you end up with this. So now what do? Now you square both sides, right? What does that left side become, Rourke?
5x plus 6.
Correct. Square root of a table times the square root of a table is a table. Over on the right-hand side, you have to make sure you multiply it by itself. So that's going to be, can you walk me through it, Katie? What's that one going to be?
9
plus
3.
And then 3 again. So how many total are you going to have? 6 of these. Yep.
X plus 3.
Plus what?
Plus 3. Or x plus 3.
Correct, because when you square it, it just goes away, right? So you now need to clean this up before, you're going to have to square again, but clean it up first. So the x cancels with the 5x, and what are you left with? 4x. And then you have 9 and 3, that's 12. What's 6 minus 12? So you have this right here. Now before you do anything else, you might want to, you might think, oh, okay, I'm going to divide by 6. But if you divide by 6, what is that going to create on the left side? Do you want fractions? No, not really. What could you divide, though, by to make it simpler but not generate any fractions? 2. When you see all evens, divide by 2. So you end up with 2x minus 3 is equal to, like this. Now, you could divide by 3, but again, let's avoid fractions. What could you do at this point? Yes, what's up, Lauren? So now, what does the left side become? 4x squared minus how many x's? 2 times 3 plus 2 times 3 is going to be 12x plus 9 is equal to, what does the right side become when you square it? 9 times. So now what land are we in? Begins with a Q.
Quadratic.
We're in quadratic land. Solve that for me, kids. Go. Need to clean this up. Just checking to see if you're in the same place. End up with 9x plus 27. So what do I subtract from both sides? 9x and 27, exactly. So you end up with 4x squared minus what, 21x? Minus what? 18 equals? So how many people got this right here? So at this point, what do you have to do? Yeah, you're going to have to factor this. Now, you might not be super happy about that because the leading coefficient is 4 and not something nice like 1. Also, 21's big, 18's big. You're going to have to factor. Did anybody successfully factor it? Calvin, what does it factor into? Oh, sorry, Jacob, what do you got?
4x plus 3 times x minus 6.
Ah, nice, it works. So if that's true, does it check? Looks like it checks. Yeah, it does. You know that 4x plus 3 equals 0, or what?
X minus 6.
Exactly. So 4x equals negative 3, x equals negative 3/4, or x equals 6. Now at this point, do you know if these work for certain? No. You just know that these are potential answers. You then would check them. Not going to do that right now, but you would check them. Yeah. Square. You need to square both sides. So you're going to end up with 6x. You're going to end up with 6 plus 2x minus 2 of these, right? Plus 1. You should end up with that after you square both sides. You should end up with that after you square both sides. Take a look at it and see if you agree. Parabolas, right? So you have a parabola that looks like this. We know, let's say it crossed at negative 2 and 2, something like that. If I were, so this equation right there would be y equals x plus 2 times x minus 2. If I put a coefficient in front of it, like 7, let's say I put 4 in front of it. Let's say I made it y equals 4 times x plus 2 times x minus 2. Does that change the zeros? Does it change where it crosses the x-axis? No. What does it change about the shape? All it does is makes it steeper. So it has the same roots. So the point is, over here, you can divide by 2 because do you care about the steepness? No, you care about the zeros. It doesn't change the zeros.
But if you're drafting.
If